I welcome you all for physics class. Okay, till last class, we have seen about the microscopes and the telescopes. So microscopes, after the microscope, the next we have seen the telescope. So there are two types of telescope. One is a refracting telescope, another one is a reflecting telescopes. So the refracting telescope uses a lens. In that, the objective lens have a large diameter and the eye lens have a small diameter. Okay, but it has some drawbacks. So to avoid the drawbacks, the advanced telescope is invented next. That is the reflecting telescope. Okay, so the reflecting telescope not has any lens. It have only the mirror system. There are two mirrors. The primary mirror is a concave mirror, and the secondary mirror is a convex mirror. Then finally, the distant object is captured by the eye lens. Okay, so that's all the theory from the lessons. Next, we are going to solve the examples, that is numericals. So the first question is question number 7. It starts from the example 7. The previous questions are related to the mirrors. So we'll start from the already last classes we have seen some questions. Now the 7th question. Look at the 7th question. A magician during a show, he makes a glass lens with the refractive index 1.47 that disappears in a trough of liquid. Okay. There is a trough that contains some liquid. We don't know what is the liquid is. Okay. During the magical show, the magician makes a glass lens. Okay, there is a glass lens with the refractive index 1.47 that disappears in a trough of liquid. So while he is going to introduce the glass lens inside the liquid, immediately the glass lens disappears. Okay. So what is the refractive index of this liquid? So we want to find the refractive index of the liquid. Okay. Also, could the liquid be water? You are going to judge whether the liquid is water or not. How to find? See. Already we know the relations. What is the relation? Two different refractive index are given. So N2 minus N1 by R, which is equal to N2 by V minus N1 by U. Okay. But in these conditions, it have both have same refractive index. So we assume N1 and N2 both also same, that is equal to 1. Then substitute in the formula how it changes. So 1 minus 1 by R, which is equal to 1 by V minus 1 by U. So it becomes 0. So in the next step, 0 by R, which is equal to 1 by V minus 1 by U. So 0 by anything, it's 0 only. So 1 by V minus 1 by U, which is equal to 0. But from length formula, already we know 1 by V minus 1 by U is equal to 1 by F. Therefore, this equation changes. So this is the first equation and this is the second equation. So second equation changes from the length formula. So instead of 1 by V minus 1 by U, we can write it as 1 by F. 1 by F is equal to 0 or F is equal to 1 by 0. So anything by 0 is equal to infinity. Anything by 0 is equal to infinity. Okay. So lens in a liquid that acts like a plain glass sheet. So lens in a liquid that acts like a plain glass sheet or sheet of glass, plain glass sheet. Another one thing, they are asking, could the liquid be water? No, the liquid is not a water because water has a different refractive index, that is 1.33. So what is another one liquid medium which have the same refractive index? That is nothing but, the liquid is nothing but glycerin. So the glycerin refractive index is 1.473. So the liquid medium is not a water and the liquid medium will be a glycerin. Very simple questions. During a magical show, the magicians, he introduced a glass lens of refractive index 1.47 in a liquid medium. While he introduced the glass lens in a liquid medium, the glass lens disappears. Okay. So what is the refractive index of the liquid medium? From that you are going to judge whether the liquid medium is water or not. So using these relations only, we are substituting the values. So from the relations, we are assuming after introducing it disappears, no? So the refractive index of the mediums are similar. N1 is equal to N2, that we assume as 1. So after substituting, then finally we get the focal length forms at infinity. So the liquid medium, this glass lens act like a plain glass sheet, and liquid medium act like a plain glass sheet, and the liquid medium will be glycerin, because different medium that have a different refractive index. Okay, so what is the refractive index indicates? So this is nothing but a number, how much times the speed of the light suffers in the medium. Okay, now we are moving to the 8th example. Look at the question carefully. So that question has a 3 divisions. So we are going to ask 3 divisions. So based on this model, we have some 5 more questions as well as 3 more questions. So in 5 more questions, we won't ask any single questions directly except the derivations. Most of the numerators will be the combination of 2 or more questions. So this is that model. So in this 8th question, we have a 3 divisions. The first one is, if the focal length is 0.5 meter for a glass lens, what is the power of lens? It's very simple. Based on this model, already we have solved some numerical. They given the focal length. The focal length of a glass lens is 0.5 meter. Then what is the power of lens? We know P is equal to 1 by F, the reciprocal of focal length. Okay, substitute. It is in meter only, 0.5 meter. So this meter and this 1 means also meter cancel. So that only we will write as diopter. So 1 by 0.5 is equal to, what is it? It is 2. So 2 diopter, that is plus 2 diopter. So first question is solved. If the focal length is 0.5 meter, what is the power? Plus 2 diopter. So question number 1 is over. Then second question. Look at the second question. Okay, we will solve from this side. The area of curvature of faces of double convex lens are 10 centimeter and 15 centimeter. There is a double convex lens. So area of curvature of the double convex lens are given here. This is R1, this plus, and R2 in the left hand side. So this comes under minus. Okay. So what are the ready? 10 centimeter and 15 centimeter. So R1 is equal to plus 10 centimeter and R2 is equal to minus 15 centimeter. Its focal length also given. What is the focal length? The focal length of the double convex lens is always plus 12 centimeter. Then what is the refractive index of the glass? So we want to find the refractive index. Okay. So already we know the lens maker formula. From lens maker formula, power is equal to 1 by F, which is equal to N21 minus 1 into 1 by R1 minus 1 by R2. Okay. So in this question, we can find it's a 1 by 12. So 1 by 12 is equal to N minus 1 into 1 by R1. What is the R1 value? It is a plus 10 and R2 is a minus 15. So minus become plus. Okay. So N minus 1, which is equal to 1 by 12. Before that, this will simplify. So 1 by 12 is equal to N minus 1 into LCM is 30. So here 3 times. So here also 3 times. Here it's 2 times become 30. Here it's also 2. So 3 plus 2 by 50. So 3 plus 2 by 50 is equal to 5 by 30. 5 by 30 is equal to 1 by 6. Therefore, N minus 1 is equal to, already 1 by 12 is there. This 1 by 6 becomes 6 by 1. So 1 on 1 6 is 2. So what is the value? 1 by 2. Therefore, N minus 1 is equal to 1 by 2. N is equal to 1 by 2 plus 1. Using cross multiplication, it is 1 plus 2 by 2, which is equal to 3 by 2. Therefore, the refractive index of the glass lens is 3 by 2. What is the value? It is 1.5. So hence we have found the refractive index of the glass. Its value is 1.5. Okay, it has no unit. So second question also over. It's a very simple question. Listen it carefully. There is a double convex lens, have the two radii of curvature. One is R1, it is in the right hand side, so it's a plus. R2, it is in the left hand side, it is a minus. Focal length also given, it is always plus because it converges the light rays. And what is the refractive index of the medium? So using a lens maker's formula, substituting all the value, finally we found the refractive index. Okay. So second question is over. Next we are moving to the third example. Look at the third question. A convex lens has a focal length 20 centimeter in air. What is the focal length in water? So question number 3. A convex lens has focal length. What is the focal length? 20 centimeter in air. If it is introduced in the water, what would be the focal length? Okay. So listen. And hints also given. The refractive index for air-water interface is 1.33 and the refractive index for glass air is 1.5. Okay. So in this case, for a glass is in air. So glass in air. So in air the refractive index is 1. So in air the refractive index is 1 and for glass the refractive index is given. What is the refractive index? It is 1.5. Okay. So for a glass, the refractive index is 1.5. Focal length also given. What is the focal length? It is plus 20 centimeter. So using lens maker's formula, from lens maker's formula, 1 by f is equal to n2 1 minus 1 into 1 by r1 minus 1 by r2. Okay, right. Substitute the value. So 1 by f1 is focal length is 20. 1 by 20 is equal to, that is n2 by n1 minus 1. Now using cross multiplication, what you will get? n2 minus n1 divided by n1 into 1 by r1 and r2. R1 and r2 value is not mentioned. Okay. Then this n1 value. Substituting the value, substitute all the values. So 1 by 20, which is equal to 1.5 minus 1, that is 0.5 divided by 1 into 1 by r1 minus 1 by r2. So this is equation number 1. This is equation number 1. Similarly, now the convex lens is placed in the water. So by placing this in water, what would be the final formula? Then using the two formula we can get the solution. This is for air, gas in the air. In second case, for same glass, actually the glass lens is in air. I forgot the lens. The glass lens is in air. Now the same glass lens is placed in water. So in this case, in water the refractive index is 1.33 and the gas is 1.5. Okay, focal length only we want to determine. Okay, use the same formula. 1 by f is equal to n2 minus n1 by n1 into 1 by r1 minus 1 by r2. So the denominator n1 we can multiply this side. So n2 minus n1. So substitute all the values. n1, what is the n1? 1.33 by f, which is equal to n2 minus n1. What is the n2 minus n1? That is 1.5 minus 1.33 into 1 by r1 minus 1 by r2. By subtracting this 2, 1.5 minus 1.33, which is equal to 0 0.17. 0.17. Okay. Then the first equations, we want only this term alone, that is 1 by r1 minus 1 by r2, which is equal to 1 by 20 already is in this side, but the 0.5 goes to that side, that becomes 1 by 0.5. So this is equation 1. We assume this is the equation 1, not this one. So this is equation 1. Similarly, from this, use 1 by r1 minus 1 by r2, which is equal to already 1.33 by f is there. This multiplication goes there, that becomes 0.17. This is equation number 2. So this is equation number 2. Okay. Compare these two equations. Compare equation 1 and 2. The left hand sides are equal. Automatically the right hand side will be equal. No. So equating the right hand side. What is the right hand side value? That is 1.33 divided by f into 1 by 0.17, which is equal to 1 by 20 into 1 by 0.5. Okay. So, but we want the focal length of the same glass slab when it is placed in the water. So, f is equal to, what is the f? This value 0.5 is nothing but 1 by 2. 1 by 2, it goes there. So, 2 by 1, so it becomes 10. So, f and 10, both your transfer. This goes to left hand side, that become multiplication. The denominator focal length you are changing to right hand side, that become that side multiplication. Therefore, f is equal to 1.33 by 0.17 into 10, which is equal to 13.3 divided by 0.17. So, what is the ratio of this value? Which is equal to 78.235. So, that is a plus centimeter. After round off the digit, the focal length is 78.23. So, for the same glass lens, when it is placed in the air, the focal length is 20 centimeter. It is given in questions. But we are changing the medium. Instead of air, now the glass lens is placed in water. When it is placed in water, that is a refractive index of 1.33. The same refractive index 1.5. What would be the focal length? We found it is 78.25 centimeter. Okay, so these model questions are very important. Same like a model, many times they asked in board exams. So kindly practice this. Very simple questions. I'll repeat once again. There is a glass lens having a focal length 20 centimeter. So it is placed in the air first. So in the air the refractive index is 1, and for glass already we know it is 1.5 is the refractive index. And using lens maker's formula, you will get one equation. Okay. Now the same glass lens is placed in water. Adhe glass lens kondu enga vechirukomna appo water la vechirukom. What would be the focal length? There is a changes. So from lens maker's formula, we will get another one equations. Comparing these two equations, the left hand sides are equal. Automatically the right hand side would be equal. Equating the right hand side, finally we got the focal length. Okay. Moving to the next question. Next question number 9. This is the last example. Okay. And just observe the diagram. We have a combination of lenses. So in these questions, there are 3 lenses. Lens 1, 2, 3. 3 also different lenses. Lens 1 and 3 is a convex lens, that is a converging lens. In between this converging lens, there is a diverging lens of concave is placed. Okay. So in this combination of a lens, at the left hand side, there is an object AB is placed. So an object AB is placed at the left hand side from the first lens at a distance of 30 centimeter. So in the left hand side distance is taken as negative, no? So it's a minus. and the distance between lens 1 and 2 is 5 centimeter, and distance between lens 2 and 3 is 10 centimeter. Okay. Find the position of final image formed by the lens of this combination. So from the light, from the object, the light is incident on the first lens, then it forms the image. Then what happens? That image acts as the object to the second lens, then the second lens forms the image, then that lens acts as a object to the third lens, then the final image is obtained. So where will be the final image is obtained? From the lens, and where? It's the left hand side or right hand side? That only we want to find. So we have a focal length of 3 different lens system. In this combination, an object is placed at 30 centimeter from this lens. So where the final image is formed? Okay. So now first, in the 3 steps we are going to solve. First, image formed by the lens 1. Image formed by the lens 1. We know the lens formula. What is the lens formula? 1 by f1 is equal to 1 by v1 minus 1 by u1. Okay. And they given the focal length of this lens, it is 10. Okay, we will write the focal length. Focal length is plus 10 centimeter, and object is placed at 30 centimeter. It is in the left hand side. So we want to find where it forms the image. And substitute all the values. So 1 by 10, which is equal to 1 by v1, we want to find 1 by u is minus 30. So minus into minus will become plus. Therefore 1 by v1, which is equal to 1 by 10 minus 1 by 30. Taking LCM is 30. So 3 minus 1, which is equal to 2 by 30. That is equal to 1 by 15. So comparing this, numerators are equal, automatically denominators are equal. Therefore v1 is equal to 15 centimeter. So this is the image formed by the first lens. So here, this distance, it forms at the right hand side. So this distance that acts as a object distance to the second lens. Okay, we'll write. So this v1 that serve as object to lens 2. So in a second case, we found out the distance. It is so we can write u2 is equal to plus 15 centimeter. And in a second case, we have the focal length. It is a diverging length. So f2 is equal to minus 10 centimeter. Then substitute in the formula. In B. So image formed by lens 2. What is the image formed by lens 2? Using lens formula, 1 by f2 is equal to 1 by v2 minus 1 by u2. So focal length is minus. So 1 by, yes, it have focal length is minus. 1 by minus 10, which is equal to 1 by v2. We don't know. That only we want to find. Minus 1 by u2 is 15 centimeter. Okay. So that is 1 by v2 minus 1 by 15 is equal to minus 1 by 10, and 1 by v2, which is equal to minus 1 by 10, this minus your transfer, plus 1 by 15. So LCM is 30. So minus 3 plus 2, which is equal to minus 1 by 30. So hence minus 1 by 30. There are some changes. So V2 only we want to find. U2, which is 15 centimeter. Yes, it is 15 centimeter. Here we did one mistake. See, this is not a 15. So already the first lens, second lens is separated from first lens. That I forgot, right? Second lens is separated five centimeter from lens 1. Therefore, what we can write? 15 minus 5 centimeter is equal to, it's a 10 centimeter. So this is the U2. Now we substitute. This is not a, this is U2 only. So 1 by V2 minus 1 by 10, which is equal to minus 1 by 10, or 1 by V2 is equal to minus 1 by 10. This you transfer that side, the plus 1 by 10, so it becomes 0. So 1 by V2 is equal to 0, or V2 is equal to 1 by 0, which is equal to infinite. Therefore, the final image in the second lens combinations, image formed at infinite. Image formed at an infinity. So, for the third lens, the image found by the second lens that acts as a object. Okay. So the image by this image by lens 2 that serves as object to lens 3. Therefore, we can come to the assumption that U3 is equal to infinite. Okay. Now we want to find the final image forms. No. So for the third case, they given the focal length. So focal length of the third lens is plus 30 centimeter, and we want to find V3. V3 is equal to what? And U3 is equal to infinite. So substitute all the value. So 1 by F3 is equal to formula already written. So 1 by F3 is equal to 1 by V3. 1 by 30, which is equal to 1 by V3 minus 1 by infinite. So 1 by V3 is equal to 1 by 30 plus 1 by infinite. Anything by infinite, 0 only, no? So 1 by V3 is equal to 1 by 30 plus 0. We have to consider. So V3 is equal to 30 centimeter. Since the third lens that produces the image 30 centimeter, it is in the plus. So at right hand side. Plus means right hand side. So the final image is obtained at 30 centimeter from third lens. Are you clear? It's very simple. I repeat once again. We have three different lenses in the convex and the concave lens, and each lens is separated by a distance. So lens 1 and 2, the distance is 5 centimeter. Lens 2 and 3, the distance is 10 centimeter. Okay. And the first lens focal length is 10 centimeter. Second lens is minus 10 since it is diverging. Third lens is plus 30. So for the first lens, the object is placed at the left hand side from a distance of 30 centimeter. So what is the final image formed by this lens combination? So these three lenses combined together and final image is formed at what distance? That only we want to find. So now we forgot lens 2 and 3. Consider only the lens 1. For a lens 1, the object is placed at 30 centimeter, having the focal length. Easily we can find the image distance. So this forms the image. So in this case, it forms the image at 15 centimeter at the right hand side. So V1 is equal to 15 centimeter at the right hand side. This image distance, this image that serves as the object to the second lens. Then final image is obtained by the second lens is infinite. Okay. Then the second lens image found by the second lens that serves as the object to the third lens. Then final image is obtained at 30 centimeter. So this is a final image formed in this combination. That is at the right hand side. Are you clear? So related to this, they may ask some other questions. They may use two diverging lens, in between that one convex lens, or a convex lens with the diverging lens. So like this combination, because many optical instruments like a telescope, microscope that uses two or more lens systems for magnification. So how to find the image distance? From that we want to find the focal length. Using the focal length we want to find the power also. Okay. So related to this model, you need to work out, and I am going to give you some questions related to that in worksheets also. So try to solve. Okay. And also go through some board question papers, the numericals which is based on this combination of the lens systems. Thank you. Coming to the next question, look at the book exercise. So till now we have seen only the examples. Now we are going to solve the book exercise. From ray optics, from book exercise, question number 1 and 2, It's from deleted portion, that is from mirror. So next we move to the third question. Look at the questions. A tank is filled with the water. A tank is filled with the water. Okay. To a height of 12.5 centimeter. That is 12.5 centimeter is the height of the tank that is completely filled with the water. The apparent depth of the needle lying at the bottom of the tank is measured by a microscope. So this is observed under a microscope. So a needle is placed originally at the bottom of the tank, but this is not the original depth. The apparent depth of the microscope is observed under the apparent depth of the needle is observed under the microscope. It is to be a 9.4 centimeter. What is the refractive index of the water? So we are going to find the refractive index of what is the refractive index of water. If the water is replaced by a liquid, okay, then up to the same height. So at what level initially we have filled the water at the same level. Now the water is replaced by some other liquid with the refractive index 1.63. By what distance would the microscope have to be moved to focus the needle again? ரொம்ப simple சொல்லணும். There is a water tank. Inside the water tank we placed a needle. Now the original depth of the water column in this water tank is 12.5 centimeter. Okay. Then the needle is placed at the bottom of the tank, which is viewed by a microscope. But the apparent depth is measured by a microscope, that is to be 9.4 centimeter. Suppose if you replace the water from the tank instead of another liquid to a same height having the refractive index 1.63, what would be the adjustment of the needle again? Okay. So now we are going to solve it. Listen. How to solve it? Okay. So in the question they given the real depth of the needle, that is original height of the water column, that is 12.5 centimeter, and the apparent depth of the needle, which is observed by microscope, also given. So the apparent depth of the needle by microscope is 9.4 centimeter. Okay. So initially in the tank water only placed, no. So the refractive index of water is ratio between real depth to apparent depth, that is 12.5 centimeter divided by 9.4 centimeter. Centimeter cancel. After dividing this, we found the refractive index, which is equal to 1.33. Therefore, the refractive index of water is 1.33, which has no unit. Now, replace the water. Instead of water, you fill the another liquid, that is having the refractive index 1.60 to the same height. Now, what distance should be the microscope to move further? Okay. In that cases, the new refractive index is 1.60. Okay. So what would be the refractive index? So the refractive index of the liquid, which is equal to real depth by apparent depth. The real depth won't change, but the apparent depth we want to find, that we are considered as y. Okay. The next one, rearrange the formula. They given the refractive index, that is 1.63, which is equal to what is the real depth? The original height does not change, that is 12.5 centimeter divided by y. Therefore, y is equal to 12.5 centimeter divided by 1.63. So by taking the ratios, so the apparent depth in this case is 7.67 centimeter. By replacing the liquid, this is the height, but they are asking you to find at what distance would the microscope have to move further to measure this needle again, to focus the needle again. In this case, you compare this two value. For the new liquid, the apparent depth is 7.67, and when the water is placed, the apparent depth is 9.4 centimeter. So, the 9.4 centimeter is greater than the new depth by replacing a new liquid instead of water. Okay. So, what is the difference between that? So, 9.4 centimeter minus 7.67 centimeter, which is equal to 1.73 centimeter. So we need to adjust the microscope further to 1.73 centimeter for the new position of the needle when it is placed in some the other liquid having the refractive index 1.63. Okay, it's a very simple question. There is a water tank that contains the water to the maximum height of 12.5 centimeter. That is the depth of the water In that, needle is placed in the bottom of the tank, which is observed under the microscope. So the apparent depth which is observed under the microscope is 9.4 centimeter. So find the refractive index of water, because refractive index, which is the ratio between real depth to apparent depth. So we found the refractive index. Now replace the water by some other liquid to the same level, but the different refractive index. In that cases, you find the apparent distance. Okay. By comparing this apparent depth in the new liquid to the apparent depth when it is placed in the water. So there, how much difference? It is 1.73. So we need to move the microscope further to 1.73 centimeter. Next we are moving to the fourth sum. The next question. There are three figures are given here. Okay. Show the refraction of a ray in air incident at 60 degree with a normal towards glass air. Okay. First one, glass air interface and then water air interface. Okay. After that given water to glass. So the light is coming from rare medium to denser medium. It bends towards the normal. So the incident ray from air that makes the angle to the normal is angle of incidence, which is 60 degree, and the refractor ray which makes the angle to the normal is 35 degree, that is angle of refraction. Similarly, to water air interface, the angle of incidence is 60 degree, that is the rare medium, and the denser medium is water, so ray bends towards the normal. Okay. So similarly, the light is going from water to glass. In that, what would be the angle of refraction? It's a very simple concept. First, we'll take for this air to glass interface. For air glass interface, let me find the refractive index of glass with respect to water is equal to sin A by sin R. Already they given the sin 60 degree divided by sin 35 degree. Sin 60 degree value already we know, 3 by 2. So the value is equal to 0.8660. Similarly, sin 35 degree from log which is equal to 0.5736. By taking the ratio, the refractive index of glass with respect to air is equal to 1.51. This is equation number 1. So for air glass interface, we found this value. Similarly, for air water interface, we can find the refractive index. For air water interface, we can find the refractive index. That is, refractive index of water with respect to air is equal to sin I by sin R from Snell's law. So sin 60 degree divided by angle of refraction is 47. So sin 47 degree. Already we know the value of sin 60, which is 0.8660 divided by sin 47 value is 0.7314. By taking the ratios, the refractive index of water air interface is 1.184. So this is equation number 2. It's over. So these two cases are over. Now the third case is here. Okay. So from the two equations, we can find the refractive index of glass. So from 1 and 2, we can find the refractive index of glass with respect to water. That is equal to refractive index of glass with respect to air divided by refractive index of water with respect to air. Okay. So what is the value? That is 1.51 divided by 1.184. The value is equal to 1.275. But in the third case, the light is coming from water to glass. So the incident ray makes angle to the normal is 45 degree. The refracted angle only we should find. But refractive index of glass to water is equal to sin I by sin R. We know the value already. That is 1.275, which is equal to sin 45 degree divided by sin R. So sin R, which is equal to sin 45 degree, which is equal to 1 by root 2. So 1 by root 2 divided by 1.275. which is equal to 1 by root 2 into 1.275. Root 2 value already we found. What is the value of root 2? It is equal to 1.414. So 1 divided by 1.414 into 1.275. So sin r is equal to, so from that we can get the sin r, which is equal to sin r, which is equal to 0.5543. So that by taking this value, by multiplying these two value with divided by 1 divided by the value, that is equal to 0.5543. Therefore, r is equal to sin inverse of 0.5543. And in natural science, you check this answer straight to the angle. You are going to find the angle straight to this answer. Usually they give the angle, we will find the value. But in a log book, with this value, straight to this value in the natural science, what is the angle? So that is the inverse, no? So the reverse. Usually they give angle, sin 30 degree, means in a natural science, straight to 30 degree, what is the answer we will find. Now, in a natural science, straight to this answer, what is the angle? It's the inverse. So the inverse value which is equal to 38.68 degree. So this is the angle of refraction. So we know already from rarer medium to denser medium, the ray bends towards the normal. Comparing angle of incidence, the refracted angle is less. So comparing angle of incidence, the refracted angle is less. Angle of incidence is 45 degree and the refracted angle is 38.68 degree. Okay. So based on this model, there is a possibility of asking some questions. So kindly practice. They given 3 cases. In each cases, you have to find the refractive index. The third case, they didn't give the angle of refraction. So we should find what is the angle of refraction. So this is a method. Thank you.